Okay, domain and range. What's a domain? Is the set of all possible x values or the x coordinate of the graph. It's called the domain. On the other hand, the range is the set of all possible y value of the graph. It's called the range. So range is the y, domain is the x. So let's look at example. Example 4, find the domain and range of the function below. The graph is drawn for you. So if you look at this graph, what are the possible x values of this graph? So if you look at the x value, just imagine you are walking on the x-axis, just like the word domain involve houses. So you're walking on the street, you can see the graph, right? Because you will continue. If you walk here, if you look below you, you will see the graph as well. So is there any way you walk where you don't see the graph? No way, right? So you say the domain is all real x. Means all the x values are possible. Okay, let's find the range. What are the range? Range is all the possible y values. So if you are, just imagine you're on the tree. This is like a tree, so you can see the graph here. See the graph? But is anywhere on here on the y-axis where you don't see the graph? Where? There, like where? -4. So what are the places where you can see the graph? -3 onwards. So you write y is bigger than or equal to -3. Get the idea? That's the range. So range is all the possible y values. Domain is all the possible x values. Okay, good. All right. And next step. No. You even if you go to 1 million, you will eventually see the graph, right? You will see it just very far away. No, it doesn't. It doesn't turn to a straight line. It doesn't. It looks steep, but then it will never become straight. It just gets very steep. Yeah, still steep. Yeah. All right, let's do the next one. How about the domain for the next question? What are the possible x values? What are the possible x values? Very good. That's the domain, greater than or equal to -2. How about the range? Range will be greater than 0. Remember, with the equal to. All right, pretty easy. Okay, good. Now we know how to get domain and range from the graph. The next question is, what if they don't give you a graph, they give you a formula? So let's do an investigation. The domain of a function without drawing the graph, we need to find a set of all possible x values that you can substitute into the function. An x value is in the domain if it corresponds to a y value. Okay, let's look at the example 5. Find the domain of the functions below by completing the table of values. Okay, let's substitute -100 into x. What do you get? -199. And then keep doing. Continuing on. -4, what about -4? -8 plus 1 is -7. 0 will be 1. 4 will be 9. 100 will be 201. So, what's a domain again? Is the set of x values that you can substitute into the function. Can you substitute any values into this function? Is there any numbers you can't substitute? No, so you say all real x. So without drawing the graph, I could work out what the domain is. All the possible x values are possible. All real values are possible. Okay, now how about the next one? Can you substitute -100 into square root? You can't. How about -4? You can't. How about 0? Yes, what's square root of 0? It's 0. What's square root of 4? What's square root of 100? So, what's the domain for this one? X has to be greater than or equal to 0. Get the idea? Because there's restriction, I cannot substitute negative numbers. So therefore, the only numbers I could substitute are 0 or positive numbers. Let's do the next bit. How about square root of 100 x plus 5? Can you substitute negative 100? Because you get negative 95, and you can't square root negative 95. Can you substitute negative 4? Yes, you can, because you end up getting square root of 1, which is 1, isn't it? Can you substitute 0? Square root of 5. And you can square root 9, which is 3. Square root of 104, 5. So in this case, there's a slight change in the function, therefore the domain changes as well. So what are the possible x values you can substitute in this function? Yeah, negative 5 or up. Very good. So you write x has to be greater than or equal to negative 5. Note that you can substitute negative 5 because you just get 0, isn't it? So it's not that every time you see square root, x has to be positive. It can be negative provided there's some numbers here, right? And the next question is there a faster way? Can we do it algebraically without doing this table of values? The question is yes. The answer is yes. So let's move on to the next page. Yes. Okay, let's look at the question again. So for this one, if you see a square root of an expression, you just have to make sure that whatever's inside the square root has to be positive. Okay? So for the previous example, if I were to find the domain of that, all you have to do is to write down whatever's inside the square root, x plus 5 is positive, and make x the subject. Get the idea? So you can do it this way, algebraically. Any question? So to find out the domain of this, just take out whatever's inside the square root, write x plus 5 by itself, greater than or equal to 0, and solve for x. Does that make sense? All right, let's move on to the next one. All right, okay. Now what we do is, let's look at different type of function where you have x in the denominator. Can you substitute negative 100 in? Yes, you can just get negative 1 over 100. Negative 4, negative 1 over 4. How about 0? Can you do 1 over 0? You can't. Because if you do 1 over 0 on a calculator, you will get error. Because you can never divide by 0. So the answer is no, you can't have 0. So that's a cross. How about 4? Yes, you can. How about 100? So you can substitute negative by positive numbers, but you cannot substitute 0. So what's the domain? All real x except x equal to 0. Get the idea? Okay, good. How about the next one? What if you change it slightly? Let's put in negative 100, so you get 3 over negative 104. How about negative 4? You get negative 8. How about 0? Can you substitute 0 now? Yes, you can. You get 3 over negative 4. But can you substitute 4 now? You can't, because you get 0, right? If you substitute 4, so you get no. And how about 100? That's okay. You get 3 over 96. So what's the domain this time? Yes, all real x except x equal to 4. So it has to be flexible. So how do we find the domain if you have polynomial in the denominator? We just need to make sure that the expression cannot be 0. So in this case, x cannot be 0. In this case, x minus 4 can't be 0, which means that x cannot be 4. That's how we get this 4 there, right? So all real x except 4. All right, now we know how to get the domain. Let's apply to these questions below. Let's find the domain of each. Okay, remember, if you see the square root, there's a restriction. What's inside the square root has to be positive. If you see a polynomial in the denominator, there's a restriction that it cannot be 0. So now let's apply this. So which part would you look at? You look at the 2x plus minus 3, isn't it? So we need to make sure this bit is positive. Yes? The 7x doesn't do anything. Just need to make sure whatever you're square rooting has to be positive. And to get the domain, you solve for x. How do you solve for x? You move the 3 to the other side, so 2x is bigger than or equal to 3, then divide by 2. That's your domain. X has to be more than 3 over 2. It means that I could substitute any number more than 3 over 2 into this function, I still get a valid answer. So if I choose to substitute a number that's not bigger than 3 over 2, for example, if I say, let's say I'm going to substitute x equal to 0, would that give me an answer? 2 times 0 minus 3, you end up getting square root of negative 3. You get invalid answer, isn't it? So if you choose to substitute a number that's not in your domain, you're bound to get nothing. So you can only, so the domain is very important. It tells you what numbers you can substitute into the formula, what number you can't substitute into the formula. Okay, let's do the next one. What strategy do you use next? It's a fraction with pronumeral in the denominator. What do? You just write 4x plus 1 must be not equal to 0. That's the only restriction. For a fraction, the denominator can never be 0. But it can be negative, can be positive, but it just can't be 0. So if you solve for x, x will be not equal to negative 1. So therefore, x cannot be negative a quarter. So your domain will be all real x except this number. So you can substitute any numbers you like except the negative a quarter. All right, that's good. See if you can work out the next one. All right, the next one is not that hard. It's a square root. So what's the restriction? You have to make sure it is. Let's get a highlighter. Let me get the highlighter here. That's the thing you look at. Whereas this bit, you look at this bit. And this one, you look at this bit. Okay? And then I just rub off. Let's do it again. Okay. So this one. Okay. This one, what you need to do, watching, it's in the denominator. So firstly, it cannot be 0, isn't it? And also, it has to be positive. So because it can't be 0, therefore, when we solve the inequality, it just has to be bigger than 0 without the equal to. Does that make sense? Because if it's equal to 0, you make the function invalid. So it has to be, see the difference between this one, where it's bigger than or equal to 0, but when it's in the denominator with a square root, you write 4 minus 5x bigger than 0 only, without the equal. So now let's solve for x. So write negative 5x is bigger than negative 4. And then you have to divide by negative 5. So write less than negative 4 over negative 5, which is x is less than 4/5. Okay? Question. Good. How about the next one? What's the domain? Anyone want to try? What's the domain for the next one? D. Well, when you ask yourself, is there any number I can't substitute into this formula? No. Does that have square root? Does that have x in the denominator? It means it can do anything. So all real x. Do you understand? You can substitute anything in here. No problem, because all you're doing is just squaring and minus. You can square any number and subtract by itself, right? You can square anything. So there's no problem. But you cannot square root any number. It has to be positive. You cannot divide any number. You cannot divide by 0. Does that make sense? Move on. All right, now we're going to look at the features of a graph. Watching. Let's continue on. Features of the graph. We're going to look at the x and y intercept of a graph. What's an x and y intercept? The x-intercept is where it crosses the x-axis. Okay? So the point A0, which is this point here, A0, is called the x-intercept. So the A in the A0 is called the x-intercept. And then 0b is where it crosses the y-axis. We call the b as the y-intercept. So as you can see, the x-intercept contains y equal to 0, right? The y is 0. And we'll solve the equation for the value of x to get the x-intercept. Whereas the y-intercept is when we let x equal to 0 because the x value is 0. We'll solve for this. So basically, this is your y-intercept where it crosses the y-axis. This is the y-intercept. And then you also have the x-intercept, which is this point, x-intercept, where it crosses the x-axis. These are the important features of the graph. So when we draw a graph, we need to find where it crosses the y-axis, where it crosses the x-axis. Let's do an example. We're not going to draw the graph yet. We'll just find the x and y-intercept of this function. So how do you find the x-intercept? You substitute that. There's no y in it, so you write y equal to x squared plus 7x minus 8. And then you write down, I'm going to find the x-intercept. And how do you find x-intercept? You substitute y equal to 0, which you get a quadratic equation. And the question is, how do you solve this equation? How do you solve it? You have to factorize. Hopefully you still remember, factorize this. So what goes inside the bracket? Plus 8 and minus 1, isn't it? So what's x? So therefore, why do we factorize? So that x plus 8 is 0, or x minus 1 is 0. So what's x equal to? Negative 8 and 1. Yes? All right. Any question? That's good. Okay. All right. How about? Oh, we haven't finished. We'll still have to find the y-intercept. Let's find the y-intercept. Y-intercept is much easier. All you have to do is substitute x is 0. So basically, you can just write f0, meaning I'm substituting 0 into x. So you write 0 squared plus 7 times 0 minus 8. What would the answer be? Negative 8 is the y-intercept. Yeah, okay. All right, good. Any question? All right, so we move on. Now, if you were to draw it, you can draw it like this. So let's try to draw this. So we got the x-intercept is where it crosses the x-axis at negative 8 and 1, right? There's the, yep. Okay, and then the y-intercept is where it crosses the y-axis, negative 8. So if you draw it, you will get a parabola. Okay, you'll learn about this later in the exercise. But now, this gives you the information where it crosses the x-axis, where it crosses the y-axis. But you don't need to do that. In the exercise, you just need to find out what the x-intercept is, what the y-intercept is. Okay, after we do this, we're going to look at example 8. You have to find the domain, which is the x values, where the graph is increasing. How do you know if the graph is increasing? That part is increasing, isn't it? Right? Increasing. And what the x value that corresponds to this? X has to be 1 onward, right? So right, x has to be bigger than 1. So from 1 onward, the graph is going upward. And what will be the domain for which the graph is decreasing? That's when this part is decreasing. So what are the x values? Has to be less than 1. All right, good question. Pretty easy. You will get this question in the exercise. And the final section is even and odd functions. This is also new. Even and odd functions. Nothing to do with even as in even numbers or odd numbers. It's just called even and odd. Let's look at an investigation. All right, new page. All right, let's do an investigation. What's an even function? The definition says that the graph is symmetrical about the y-axis. Is this graph symmetrical? Yes, it is. So we say it's an even function. We need to find a way of proving it's an even function without drawing the graph. How do I do that? Let's do a table of values first. I want to substitute -3 into the x. Actually, find out what f -1 is. Actually, do the table of values. So f -3 will be 9 minus 3 will be 6. Substitute -2 will be 1. Substitute -1 will be -2. Substitute 0 will be -3. All right, finish that. -2, 1, and 6. Write it down. Once you do the table, let's write down what f -1 is. What's f -1? Means that you substitute -1 into the function. What's the answer? -2. F -2 is 1. F -3 is 6. Do the same for the other one. F1 is -2. F2 is 1. F3 is 6. So what can we conclude? That f -1 is same as F1, isn't it? What's f of -2? It's same as F2. And what's f -3? Same as F3. So what property do we see for an even function? A function is even if f -x is same as fx. So that's how we prove whether a function is even or not, by doing this. Okay? Alright, let's do that. So to prove whether the function is even, whether it's symmetrical about y-axis, is to prove this rule is true. That we have to prove that it's true for all x values, not just these -1, -2, -3, everything. That's why we replace it by x. So now we're going to prove whether these functions are even or not without even drawing. So g of x, so what you do is you substitute -x into g. Alright, that's your first step. And then change the x into -x. Yes? Now, what happens when you square -x? What do you get? You get positive x squared, right? Because when you square -x, it means -x times -x. And when you times negative by negative, it's positive. So you get positive x squared plus 1. Now, what's this? This is exactly same as itself. Does it fit that definition? I've proven f -x equal to fx, like g -x equal to gx. So you say, therefore, is an even function. So it's very easy. So basically, if you were to draw the graph, it will be symmetrical about the y-axis. We don't have to draw it, but if we were to draw it, that gives us a clue that the graph will be symmetrical about the y-axis, which will help us to draw the graph. Now, of course, this is an easy one. How about the next one? A little bit more complicated, just a little bit more algebra. Have a try. Your first step, substitute -x in. Okay? What does it give you? Remember, put a bracket around it. -x power 4 minus 3 -x squared plus 8. Okay, let's move on. Watching. And then you do 5. -x power 4 will be 5x power of 4. Can you see that become positive? Hopefully you can see that. If you don't, just do this. -x power 4 means that -x times -x 4 times. And when you times it 4 times, you get positive x power 4. Okay? Same thing for the other one, you get positive. So basically, every time you see even powers, it's going to be an even function, right? It's going to be itself. And whenever you can prove h -x equal to hx, you'll say, therefore, is an even function. It will be symmetrical about the y-axis. So in the exam, if the question asks you to prove it's an even function, you do this. Okay, you do that every time. All right. Okay, we're almost done. The next question is an odd function. What's an odd function? An odd function, if its graph symmetrical about the origin. Now, how do I show that to you? I'm going to trace this. All right, good, nicely done. Now, watch this. What's an odd function? Odd function is if I rotate this about the origin, right? 180 degrees. Oh, it didn't work. Huh? Didn't work. Oh, maybe it's not rotating about origin. Okay. Maybe it's a bit. So if you rotate this about the origin, you look the same. It means it's an odd function. Get the idea? Right? So if you rotate it about the origin, it will look the same. Actually, the reason why it didn't work because maybe it's not evenly distributed. Okay, hang on. Let me just make it a bit equal. It should work now. Let me try again. One more time. Okay. So if I rotate about the origin, yeah, yeah. Okay. It will be, it's an odd function. Okay. All right. All right. Let's do this now. Again, we need to have some formula, something like this, but not going to be like this. This is even. Let's see. Let's investigate what will happen if it's odd. So we substitute -3 into x. You get -27. -2 into that into -8, which is -1, 0, 1, 8, 27. Okay. And like before, let's see if there's any connection between the two function values. So write -1, +1, -8, +8, -27, 27. So they are sort of equal, but not exactly equal. They are sort of negative of the other. So what can we conclude? That means if I substitute -1 in here, it's same as negative of 1, right? Negative of 1, right? Because this is negative of that. And if you do that again, f of -2 is same as -f2. And f of -3 is same as -f3. Yes? Now, so a function is an odd function if f negative x equals to negative fx. So you have an extra negative. That will be an odd function. And we'll do some examples of that. So to prove it's an odd function, make sure you have an extra negative outside the function. We're going to prove it. So there's even and odd. Of course, there's neither as well. Neither means neither of these work. Okay, let's move on. Hope you all finish. Okay, all ready? All right, one more page. That's it. Prove the following function are odd. Let's see what we do. So we substitute -x in. 3 -x cubed. When you cube a negative number, you get a negative. So you end up getting 3 times -x cubed. When you cube a -x, you get -x cubed. Okay? And that negative has to be taken out. Now this, remember, is this, which is ix. So I'm going to replace by ix, but you have an extra negative in front. So what does it say? It means that, therefore, the function I is an odd function. Very easy. You just have to make sure there's a negative, extra negative. So the negative is not, didn't disappear, but actually stay in the expression. Okay? It's an odd function. Try the next question. Very similar. Okay, let's try this. K -x. Yep. All right, have a try. So what do we get? So we get -7 -x to the power 5 minus 3. Make sure you put brackets. See, every time I do this, I put a bracket around it. And what happens if you raise the -x to the power 5 means negative x power 5. Double negative is plus 3x. And you get negative 7x power 5 plus 3x. Now, you have to take out negative. There's two terms. You take out the negative. So you take the negative out and write 7x power 5 minus 3x. I took a common factor of negative. Get the idea? And then what happened here? Why do I need to do this? Because this is this thing, right? Which is kx. So you have to express in terms of the negative of kx with an extra negative in front. So what can we conclude? Therefore, kx is odd. Okay. Should write is odd. Is an odd function. Is an odd function. Alright, so now we know how to prove it's odd, how to prove it's even. The question will usually say, classify whether even or odd or neither. So you need to tell. So how do we do this? Let's do all of it. So sometimes even, sometimes odd, sometimes neither. Let's do the example. So usually, when you see the odd powers, it's going to be odd, right? But when you see here, that's going to be even. Okay. Let's do the first question. Okay. Let's substitute negative x. That could be an odd function, but just be careful. Put negative x in. Negative x to the power 3 over 7 negative x cubed plus negative x to the power 5. And then take your time. When cube and negative, it becomes negative x cubed. Again, negative 7x cubed, negative x power 5. Lots of negative. But you will see that negative actually gets cancelled. So if you take the negative out, you get 7x cubed plus 5x power 5. Like that. And that negative gets cancelled. So what do you have left? You have this left. Now, is it equal to itself? It is. It's equal to the one on the top. So what can we conclude? It is even. So be careful, not always you have odd powers, you get even. Odd, you get even. Maybe that's where the word comes from. Even function usually have even powers. Odd functions has odd powers. But when you have odd divided by odd, you end up getting even. Yeah? Alright. Let's try the next one. See if it's odd or even. Let's do this. F negative x. Negative x squared, negative x cubed, negative x. And when you square the negative, becomes positive. Cube the negative, become negative. Double minus is plus. Okay. Alright, so what do we do next? Okay, now we have to factorize. Like we did before, factorize the negative out. But there's no negative on the top. So therefore, there's only one negative. That survives. So you got negative x squared over x cubed minus x. Now what's this? This is exactly the original, which is the fx. So you got the extra negative fx. So what does that tell you? It is an odd function. So you can see when you divide even by odd, you get odd function. But odd divided by odd, you get even. Right? The top is an even, the bottom is odd. Two more to go. One more, then we're done. Okay. C, would that be an odd function or even? Alright, if you cube a negative x, what do you get? Negative x cubed. Now this one, there's a problem. Obviously, it is not even, right? Because it's not the same. But is it odd? Let's take out the negative. It's different, right? This is different from that. It's not equal to the negative of itself. So what can you conclude? We'll say it is neither. It's neither even or odd. It's just neither. It doesn't. Not every function is even. Not every function is odd. Because not every function, not every graph is symmetrical about the y-axis, which is even. Not every graph will be symmetrical about the origin, which is odd. Because some graphs look like this, which is not, which neither, right? So it doesn't have to be even or odd. So you just say it's neither. How about the next one? Would that be even or odd? Let's test it out. F negative x. Negative x squared minus 2 negative x minus 8. Right? When you square the negative x, you get x squared. Double minus is plus minus 8. Now, is that same as itself? No. Not equal to fx, so it's not even. Let's take out a negative. If I take out the negative, you get negative x squared minus 2x plus 8. Actually, yeah. Which is not equal to the negative of itself. So it's neither equal to itself nor negative of itself. You say it is neither. Yeah. So today is pretty complicated. Domain range, x and y values, even and odd functions. But before we finish, let's link it to the previous topic. Remember what this is. That was in your exam anyway, or you were tested. What's sine negative x? It's like negative x in the fourth quadrant, so it's going to be negative sine x. What does that tell you? Sine x is a odd function. How about cos negative x? It's even. Well done. Even function. How about tan? Odd, because yeah, tan negative x equal to negative tan x. Yeah, all the stuff of function. Yes, you had enough. We'll just finish. Thank you. All right. So